One of the important aspects of speech science is quantifying various activities related to speech. This includes quantifying respiration. We use a variety of measures to quantify respiration. The respiration rate in terms of breaths per minute, which is similar to a frequency. The amount of air moved, usually in liters. The pressure that's usually used to move air in centimeters of water displacement or millimeters of mercury displacement, or the rate of air flow in terms of the number of liters per second that are moved. The devices used to make these measurements are covered in Chapter 3. We can use these measures to describe typical breathing. We can also use these measures to provide somebody's performance limits, and we can compare these measures to normative values when looking at people with possible respiratory problems to see if they have a respiratory disorder that's affecting their speech. The respiration rate in adults is typically 12 to 18 breaths per minute. During heavy exercise, the respiration rate can increase to around 21 for males or 30 for females. There are changes in respiration rate across the lifespan, with higher respiration rates for children, highest for young infants when they're first born, and then gradually decreasing toward adult norms by the age of 16 or so. Quantifying the volumes and capacities used in respiration is a common means of determining somebody's respiratory abilities. Volumes are single definable quantities. The tidal volume is how much air is moved in a breath cycle. The inspiratory reserve volume is your potential to inhale additional air. Your expiratory reserve volume is your potential to exhale additional air. And your residual volume is the amount of air in the lungs that cannot be exhaled. There's always some air remaining in the lungs to keep them from collapsing. Our respiratory capacities are combinations of these volumes. So the total lung capacity is all of these volumes put together. The amount you take in a breath, the additional amount you could have inhaled, the additional amount you could have exhaled, and the amount of air that you can't move. Put all those together and you have the complete size of the lungs in terms of how much air they can hold. The vital capacity is the measure of all the functional volumes, so the tidal volume, the inspiratory reserve, and the expiratory reserve, basically everything that you can use in the lungs, leaving out the residual volume. The functional residual capacity is the combination of the expiratory reserve and the residual volume, so the total amount of air that's in the lungs after exhalation. The inspiratory capacity is the tidal volume and the inspiratory reserve, or the amount of air that you could inhale after exhaling. This chart gives you an idea of how these different volumes and capacities combine together. So on the left we have a blue line that's going through cycles, much like the cycles for sound frequency that we looked at, but in this case it's breath cycles, changing over time. The tidal volume is the amount of air that is exchanged in a breath cycle, so most of the smaller cycles are marked by the tidal volume in this case. Given that tidal volume, the inspiratory reserve is extra air you could inhale, and there is one breath cycle with a maximal inhalation and a maximal exhalation that demonstrates these reserves. So the inspiratory reserve is the amount above that tidal volume you could go. The expiratory reserve is the amount below that tidal volume you could go. The residual volume doesn't have a blue line in it because you can never use that air. That air always stays in the lungs. The inspiratory capacity then goes up from the low point on a breath. The functional residual capacity goes down from a low point on a breath. The vital capacity is all that movable air except for the residual volume, and the total lung capacity is all of those volumes together. The tidal volume is usually the volume of a typical breath in quiet breathing, but it can be used to describe any one particular breath. that someone is taking. Typical values for adult quiet tidal breathing is about 3/4 of a liter for a male and just under 1/2 a liter for a female. Tidal volume changes over the lifespan with increasing tidal volume as children grow, from 0.2 liters at a young age to near adult values by the time they reach 16. And as with many of these measures, gender differences beginning to emerge at puberty around age 13. The inspiratory and expiratory reserves are additional volumes that can be inhaled or exhaled after or around a tidal volume, I should say. In typical quiet breathing, an adult's inspiratory reserve is 1.5 to 2.5 liters, and the expiratory reserve is 1 to 2 liters. These reserves change over time. So at a younger age, expiratory reserve is smaller, and adult levels are reached again around age 16. Expiratory reserve also declines during aging, reducing to around 1.5 at age 50 and 1.2 at age 75. And there are gender differences in these reserves, with values for males being larger than values for females, in part because males are overall larger than females. The residual volume is the volume of air that is always in the lungs. Typical adult values are between 1 and 1.5 liters. There are gender differences based on size, males' values being larger than females. Residual volume increases over childhood as the child grows, from about 1/2 liter at age 7 to adult values at age 16. But then residual volume continues to increase with aging, up to around 2 liters on average by age 75. So the amount of unusable air in the lungs increases over the course of the lifespan, making respiration potentially more challenging for older adults. The book contains a variety of tables with detailed values at different age levels and for males versus females for residual volume, as well as many of the other measures that we'll talk about. The vital capacity could be the most important measure. That's the amount of air that you can move in total through inspiration and expiration, a measure of your maximum ability. An average adult value is around 5 meters, again with differences in adults for males greater than females. This increases with development in childhood from about 1.5 liters at age 7 up until adulthood. And then as adults get older, this decreases with aging, in part because of the increase in residual volume. So as residual volume increases, the amount of usable air in the lungs, which is the vital capacity, decreases. Vital capacity is often looked at as a relative measure, since it's the usable quantity of air. We can view patterns of inspiration and expiration within this usable quantity of space, where 100% is the full vital capacity and 0% is the lungs as empty as they can be, the only volume left being the residual volume that cannot be exhaled. Using relative measures helps reveal similarities in how people breathe for different vital capacities or different total lung capacities for individuals of different sizes. Typically, that quiet tidal breathing for life purposes, for oxygen and carbon dioxide exchange, uses about 10% of the vital capacity. And the natural resting state for the lungs, if everything is relaxed, is at about 38% of vital capacity. The total lung capacity is the size of the lungs, the total of all the volumes in the lungs. Adult values are about 5 liters for females and 6 liters for males. Gender differences emerge in childhood around age 13. There is development throughout childhood from about 2 liters at age 7 to adult-like values around age 16. Total lung capacity does decrease slightly with advanced age. The peak in total lung capacity is usually around age 50. between the increase in residual volume and the decrease in total lung capacity. That is what results in that aging decrease in vital capacity for older adults. The functional residual capacity is the amount of air in the lungs at the end of an expiration. That's the residual volume, the air you can't move, plus your expiratory reserve, the amount of air that you could exhale. Typical adult values are 2.4 liters for females and 3.1 liters for males. This changes through development of childhood, starting at about a half a liter at age 7 up to adult values. Gender differences emerge at puberty around age 13. Again, larger values for males than females because of larger size. Functional residual capacity decreases slightly with advanced age. There's a peak around age 50, much like vital capacity. With increase in residual volume, some increase in functional residual capacity is accounted for by that, which isn't really a functional capacity. I find the title functional residual capacity to be a little bit of an odd title, since some of the air in that functional residual capacity is the residual volume, which isn't functional at all. That's air that stays in the lungs that you can't do anything with. The inspiratory capacity is the amount of air that can be inhaled at the end of an expiration. So that's your tidal volume, your amount of your breath, plus the additional amount you could inhale. Adult values are about 2.6 liters for females and 3.6 liters for males on average. This develops over childhood from a value of about 1 liter at age 7 and increases. Gender differences emerge around puberty at age 13. Inspiratory capacity decreases in older adulthood and seems to do so slightly more for females than for males.